In the general population, it is known that 12% of all people carry a gene that predisposes them to a condition known as syndrome K. A sample of 25 people is randomly selected to determine if any carriers of the gene are present. So if the random variable x is the number of those in the sample who are carriers of the gene, describe the distribution of x. Well, it's going to be binomial. We're talking about the general population, so we can assume that the probability doesn't change, or if it does change, it changes by such a minuscule amount we can consider it to be a constant probability. So it's binomial, and we're choosing 25, and the probability of success is 0.12, finding somebody who actually carries the gene. Determine the probability that 3 of the people are carriers, so that's probability x is 3. So we can just go straight for the calculator in this case. And so we want a binomial, in this case PDF. So it's going to be 3, number of trials is 25, probability of success is 0.12. So 0.2387. And there are no carriers, so that's just the probability of x being equal to 0. And I can actually just go back and edit this one. Just make that 0 there. And 0.0409. If 10 random samples of 25 people are selected, determine the probability that at least one of these samples has no carriers of the gene. So we're taking now 10 samples of our samples. It's still a binomial. The probability of having no people is 0.0409, and we want the probability that y is greater than or equal to 1, at least one of the samples. So that's just going to be discrete binomial CDF this time, with a lower of 1, and we're taking 10 trials this time, so an upper of 10. With 10 trials, probability of success is 0.0409, and that is 0.3414.